Okay, so on to the derivative review problems. Number one, we see a function that has a high piece and a low piece, a numerator and a denominator, so we're going to invoke the quotient rule here. So the quotient rule, we're going to take the low function, perhaps. We'll take the low function at some point. And then take the derivative of the high function. Subtract the high function now. And multiply by the derivative of the low function. All divided by the function, the low function, squared. Okay, so that was the low, and if you're scoring at home, low d high minus high d low all over low squared. So there's what we have. We can simplify that a little bit. We need to make it look like one of our answers. So that doesn't look like one of our answers just yet, but we'll see. So we'll get, on the numerator, we'll get x squared plus 1 minus 2x squared. I'm not going to write the denominator because this thing just goes too slow. All right, so same denominator, and I can tell that what I'm going to get here is a 1 minus x squared. I'll have a negative x squared, so that'll be that, and I'll be left with all over x squared plus 1 squared. And I think that looks like one of our. We have a winner. It's D. All right, so focus on applying the rule correctly, and then work step by step through your simplifications, and then you should find an answer that matches. All right, moving on. All right, number 2. That one, you think, what's it doing here? It has a limit. Well, remember, the way we took and we looked at the limit definition of a derivative. We looked at the secant line, and we took the secant line as it got closer and closer and closer, as the points got closer and closer and closer together. So we wanted that distance between them, which we called h, to be smaller and smaller, so we could find the instantaneous rate of change. So whenever we see a setup like this, we have a function that has its function minus something that it's going to be evaluated at, and the mirror image on the bottom, or as h approaches 0 with h down here, we know that we're just looking at the derivative. All right, so there's nothing special we're going to do. We're not going to try to evaluate this crazy thing. We know that this is just the cosine evaluated at pi over 4. Nothing more, nothing less. All right, so because the derivative of sine is cosine. Okay, so you need to recognize that form. Whenever it comes up, they're trying to trick you and think you got to do something crazy, but no. So the cosine of pi over 4 is root 2 divided by 2. Okay, if g of x equals the cosecant of 2x squared plus 1, then g prime of x equals. All right, so here we're going to do the chain rule. And we will go ahead and look at the derivative of cosecant, which is negative cosecant cotangent of x. So to do the chain rule, we're going to evaluate our outer function, our outside function, and this would be our inside function. So the derivative of cosecant is negative cosecant. We leave the inside stuff as it is. And then times the derivative of all the stuff on the inside, which is 4x. So our answer, 4x, is going to come out to the front. If we can just kind of see through our annotations. We're going to have a negative 4x, and then a cosecant and a cotangent of the same thing. So it looks like E E is our match here. Hopefully we can just undo what we did. All right. So E, as I was saying, E is our answer. All right. So number 4. Okay. The tangent squared of 8 minus 2x, then f prime of 1 equals. And I think I forgot my f of x. So, all right, we'll take the derivative first, and then we'll plug in substitute 1. So we have 3 functions here. We have a squared function, and then we have a tangent function, and then we have this function. So our outermost function, and we can rewrite this as this, if that helps you think of it that way. So then we're going to say 2 times the tangent of 8 minus 2x. Okay, that's our outer function. Then we're going to say times the next function, which is the tangent. So times secant squared, that's the derivative of tangent, with the stuff inside still staying the same. And finally, at the end, the derivative of the most inside stuff, negative 2. Okay? So it looks like we are going to have negative 4. And if we also substitute 1 at the same time, tangent of 8 minus 1, 2 times 1 is 2. So that's where the answers are having 6 come into the picture. And then the secant squared of the same bit, 6. That's a bracket. Okay, so negative 4, tangent of 6, secant squared of 6. And make sure that your squares and your tangents and secants are all right, and we look at D. Okay, moving right along. On to number 5. Ooh, some implicit. All right. So we have 3x squared minus 2xy plus 3y equals 1. Then when x equals 2, dy dx equals. All right. So let's find this. So first of all, we have to evaluate our derivative. So we're going to say 6x, and what really is dx, but I'm not going to write that. A, it takes too long, and B, it's just going to be 1. So every time I take a derivative of y, I'm going to remember to put the dy dx. Okay, so the next one I have a chain rule, because I know that 2x is a function, times y is another function. So I'm going to use the product rule here, so which is the first function times the derivative of the second, plus the second times the derivative of the first. So I'm going to do this. First function times the derivative of the second, plus the second function times the derivative of the first. And then plus 3, which is the derivative of 3y, times dy dx equals 0. Okay. So let's clean this up a little bit. We have 6x minus 2x dy dx minus 2y plus 3 dy dx equals 0. I'm going to move the pieces over. So I'm going to say 6x minus 2y equals 2x dy dx minus 3 dy dx. So like that. I'm going to factor out 2x minus 3. So then my final answer is going to be 6x minus 2y divided by 2x minus 3 equals dy dx. Okay, I want to find out what that is when x equals 2. But little problem, I have a y in here that I need to account for. So what I need to do is plug 2 in my original function first so that I can find the y value, and then I'll be able to go and find what dy dx equals, because I'll have a y value. So just do that real quick. 3 times 2 squared minus 2 times y plus 3y equals 1. Alright, so 2 squared is 4 times 3 is 12 minus 4y plus 3y equals 1. I get negative y equals negative 12, or I'm sorry, equals negative 11. So then y equals 11. Alright, so I'm going to plug x equals 2 and y equals 11 into my derivative here. This is what I was supposed to do all along. And this is not number 6. Okay, so now I've got 6 times 2 minus 2 times 11 divided by 2 times 2 minus 3. So that is 12 minus 22, all divided by 4 minus 3, which is 1. That makes it nice, and that's just going to be negative 10. Alright, so dy dx is negative 10. A lot of work. Really, it's the simplest forms of the derivatives. It's just understanding where you're going with it, and then understanding at the end that you need a y value, and you can only get that from using the original function up here.